In this section, we're going to work on factoring special patterns, which is going to be the same method factors that we're going to have, but the only difference is there's special patterns that help us get through the factors faster. Okay, and there's basically going to be 3 different ones, and 2 of them are the same, so it's all should be a pretty quick pattern. Okay, so here's the first one, and the most common one right off the bat is going to be your difference of squares pattern. The thing that's nice about these is your difference of squares pattern is the same as the difference of squares pattern in the first half where we multiplied. Here, if I have a perfect square, a squared minus a second perfect square, b squared, it's going to factor into a plus b times a minus b. The only trick is you have to find what that a and b value are. So here, if I have x squared minus 9, x squared is a perfect square. So you multiply x by itself to get x squared. So x times x is x squared. So that means your a value is x. Here, my b value is 3 because 3 times 3 is 9. So my b value is 3. So it factors into x plus 3, a plus b, times x minus 3, a minus b. Okay, so first things first, let's check. Is it a difference of squares? Perfect square, yes. Minus a perfect square, yes. We just have to find the a and the b value. Well, what do I multiply by itself to get x squared? Well, that's x. So that means my a value is x. What do I multiply by itself to get 25? Well, that number is 5. So my b value is 5. So what does it factor into? It factors into a plus b, x plus 5, times a minus b, x minus 5. Okay, b is also a difference of squares pattern. As I look at it, 4z squared, okay, is a perfect square. What do you multiply by itself to get 4z squared? Well, you multiply 2 by itself to get 4, and you multiply z by itself to get z squared. So the a value is 2z. Okay, what do I multiply by itself to get 1? Well, that's 1, so my b value is 1. So it factors into a plus b, which is 2z plus 1, times a minus b, 2z minus 1. Okay, pause the video and try monitoring progress 1 and 2. Okay, 1 is, again, both of these are difference of squares pattern. Okay, here where your a value is going to be y and your b value is going to be 6. Because y times y is y squared, 6 times 6 is 36. So my a value is y and my b value is 6. So this factors into y plus 6 times y minus 6. Okay, 2 is also a difference of squares pattern. What do you multiply by itself to get 16h squared? Well, you multiply 4 by itself to get 16 and h by itself to get h squared. The right-hand side is going to be 7 to the second power because you multiply 7 times 7 to get 49. So that means I have an a value of 4h and a b value of 7. So this factors into 4h plus 7 times 4h minus 7. Okay, the next type of special pattern is going to be a perfect square trinomial, where what we do is if it follows this pattern, a squared plus 2ab plus b squared, that means it's going to factor into 2 things of its equivalency. So what you have to do is you have to check, is the first term and the last term a perfect square? Okay, if it is, you ask yourself, what are the roots of each of these, or what's the a and the b value? What multiplies by itself to get x squared? X, so the a value is x. What multiplies by itself to get 9? B value is 3, because 3 times 3 is 9. Then you have to check the middle. That's really the only hard part or main difference is you do have to check the middle. Is the middle 2 times a times b? 2 times a times b. If it is 2 times x times 3 is 6x, it's going to factor into x plus 3 squared. The other formula is the exact same. The only difference is there's minus. Okay. 2a, as I look at this, I'm identifying my a value being a perfect square. So what do I multiply by itself to get n squared? That's n. I'm going to jump all the way to the n and say that 4 to the second power is 16. So my b value is 4. Now I just have to check the middle, and I'm going to write this in a different color because I'm checking it. 2 times n times 4. Is that 8n? 2 times n is 2n. 2n times 4 is 8n. Yes, it is. Since it is, that means it's confirmed that my a value is n and my b value is 4. So this factors into n plus 4 to the second power, or n plus 4 times n plus 4. So really just check the outside parts and then verify the inside is all you have to do. Okay, so 2b. Same thing, I'm going to check the first and the last term. The first term is a perfect square. Okay, so this is going to be 2x to the second power, because 2 times 2 is 4. X times x is x squared. So now I'm going to jump to the end, which is a perfect square also, because 3 times 3 is 9. Now the middle part, I just have to verify. Is it 2 times 2x times 3? Well, let's check. Negative 2 times 2 is negative 4x. Negative 4x times 3 is negative 12x. Yes, it is. So that verifies my a value is 2x and my b value as 3. So what does this factor into? This one factors into 2x minus 3 to the second power, because this is a minus in the middle, so it's a minus in the formula. Okay, go ahead and move on to the next problems, but I do want to warn you to be careful on number 4 because there's a greatest common factor. Okay, assuming that you've already paused the video and tried it. So let's go ahead and check these. Okay, this one is a perfect square trinomial, because if I square m, I get m squared. And if I square 1, I get 1. And the middle is 2 times m times 1. Since it is, that means my a value is m and my b value is 1. So this factors into m minus 1 squared. Okay, this one you got to be careful. It's got a greatest common factor of 9. So I need to take that greatest common factor out. Okay, and so then now what I do is I have a z squared. That is the perfect square. You multiply z by itself to get z squared. 4 is a perfect square also. So it's 2. And so then the middle is going to be 2 times z times 2, which is verifying. 2 times z is 2z. 2z times 2 is 4z. So yes, this factors into z plus 2 to the second power, but that times 9. Okay, so that's it in its simplest form. So make sure you check for greatest common factor like we did in the first section. Okay, so as I've mentioned, there's a lot of word problems that have revolve around area, but there's also some problems that kind of revolve around gravity. And so those are the problems that we're going to work on today. A bird picks up a golf ball and drops it while flying. The function represents the height, y, and feet of a golf ball t seconds after it's dropped. So y is height. T is time. And I have this equation here. The ball hits the top of a 32-foot tall pine tree. After how many seconds does the ball hit the tree? So it tells us that this pine tree is 32 feet tall. Okay, that is a height. And what's representing height? Y. So we know that y is equal to 32. So I can replace 32 with y. Okay, if I want to use the zero product property to solve this, I have to have it set equal to 0. This is 49. Okay. And then I need to solve. Okay, so here I need to solve for t. So here, this is the difference of squares, where I have it set up as 7 to the second power minus 4t to the second power, because 7 times 7 is 49. 4t times 4t is 16t squared. Okay, so this factors into 7 plus 4t times 7 minus 4t. So I would set each of these equal to 0 using the zero product property. Minus 7 Divide by 4t. Divide by 4. So this is negative 1.75. Okay, and this is not going to be our answer because we're not going to have a negative time. So what I'm going to do is do the other one. Here I would minus 7. Here I get t is equal to positive 1.75. And this makes more sense because it's going to be a positive time. It's not going to take a negative amount of time for something to fall. It's just going to take a positive time. It's always moving forward. Okay. So this is just kind of the same concept of using the zero product property to solve equations. You just kind of have to know where the numbers plug into. Okay, let's go ahead and move monitoring progress number 5. And pause the video and try it when, check it with me when you're done. Okay, so what if the golf ball does not hit the pine tree? After how many seconds does the ball hit the ground? So here, if the ball is not hitting the pine tree, it's hitting the ground. Okay, y represents the height of the ball above the ground. So in this situation, y is equal to 0, which is convenient because then I don't have to set it equal to 0 for the zero product property because it's already done for us. Okay, so then I can just begin to factor where this is a difference of squares, where the a value is 9 and the b value once again is 4t. Because 9 times 9 is 81 and 4t times 4t is 16t squared. So this is going to factor into 9 minus 4t times 9 plus 4t. And then I take each of these factors and set them equal to 0 and solve using the zero product property. So here I get t is equal to 2.25. We know that this is going to be the answer because the other one is just going to be negative. Okay, and so then it's going to take 2.25 seconds for the ball to hit the ground rather than the top of the tree. So it's going to be another half a second before the ball actually hits the ground. All right, that's it for the day. Go ahead, work on your practice problems and then progress toward your learning targets.